Hello everyone. In this video, I am going to explain the operation of boost converter. Boost converter is another type of DC to DC converter, and we are use this boost converter to step up the voltage. And here you can see the basic diagram of the boost converter. We have voltage source, it is input voltage, inductor, diode, and switching element named as Q, capacitor, and our load denoted as R. The components are similar to the buck converter. In buck converter also we have one inductor, one diode, one capacitor and one resistor and one switching element. In here also we have the same component, inductor, diode, switching element, capacitor and load resistor. The only change is the arrangement is different. In here also the Q is act as a active switch. This Q is named as active switch. We are using power semiconductor device for that switch, MOSFET or IGBT as this active switch. We can operate this switch with higher frequency value. And this diode is act as a passive switch, D. It is an uncontrolled power semiconductor device. And I explained the boost converter is used for step up the voltage. Then V out is always greater than the Vs. Vs is the input voltage. We are using this converter for step up the voltage. Then V out will be always greater than the Vs. Now we will consider the operation of this Q switch. What happens when the switch is on and what happens when the switch is off. In the previous buck converter video, I explained there are three modes of operation for this DC to DC converter: CCM, continuous conduction mode, and BCM, boundary conduction mode, and discontinuous conduction mode, DCM. In this video, I will explain the operation of continuous conduction mode for this boost converter. Now let's move to the operation of switch is on and switch is off. First, consider the boost converter Q is on. When Q is on, this path is short circuit. This one is short circuit. And these 2 points are equal. Then, if we consider the current path from the source, you can see the current will go through the inductor and through the Q switch, because these 2 points are short circuit and there are no any current through the diode. No any current is flowing through the diode to the load. Then current path is in this direction and inductor is start charging in this polarity plus and minus. And if you write A and B here and Q short circuit, inductor is charging from the source. And if we consider the voltage between these 2 points A and B, it is VAB, it is equal to voltage across the inductor VL, and these 2 points are short circuit, then it will be equal to the supply voltage, and it is equal to the supply voltage Vs. During Q is turn on time, the voltage applied to the inductor is equal to the supply voltage. Now we will consider the switch off period. This is the switch off period. This one is open circuit. And the inductor is now release its energy. Previously the polarity is plus and minus. Now it changed the polarity in the other direction, minus and plus. This point is A, this point is B. And now inductor is release its energy. Q is open circuit. Inductor release its stored energy. If we consider this arrangement, the inductor is act as a source, and also our voltage source is act as another source. Then from those two sources, the current will go through the diode. And diode is forward bias, and current will go through to the our load, this resistor, and this is the current path during the turn off time. The Q is open circuit, and this inductor is act as a voltage source, and there are two voltage source, the main voltage source and the inductor, and current will go through the diode to the load, and this is the current path. And if we consider the VAB, voltage across the inductor, if we write the Kirchhoff voltage law for this Vs, VL and Vout, we can write Vs, I am considering this direction, Vs plus, because the second mark is plus, plus VL, and the load resistance is getting plus and minus polarity, minus V out is equal to 0. We can write Vs plus VL minus V out is equal to 0 according to the KVL. Now from this equation, we can get VL is equal to V out minus Vs. I previously explained always V out is greater than Vs, then we can get a VL for positive value. If we write VL is equal to Vs minus V out, if we write the equation according to this arrangement, this answer will give a negative voltage. The main reason is V out value is greater than the Vs value. The output voltage is greater than the supply voltage. Then we will draw the graph for operation of the switch, inductor current, diode current, and inductor voltage. If we consider the operation of Q, this time is dt, duty cycle times total time, and during this period, Q is on, and during this period, Q is off. If we consider the inductor current during Q is on, inductor stores energy from the source, and inductor current will start from the IL min and go up to IL max. IL min to IL max. This is operate in CCM condition, continuous conduction mode. Then the current will never go to zero. It will start with IL min and go up to IL max. And if we consider the turn off time, inductor release its energy, then the IL min again come to the IL min during this turn off time. This value will be IL min. The current will gradually decrease to IL min. And if we consider the diode current during turn on time, there are no any current flow through the diode, then current through the diode is zero. And during the turn off time, the current will go through the diode from the inductor and the source. Then we can obtain this kind of gradually decreasing current through the diode during the Q is turn off. And the last one is inductor voltage. If we consider the turn on time, we can obtain the inductor voltage is equal to the supply voltage Vs. It is constant value. It is equal to Vs during dts 0 to dts time. And during turn off time, we can draw whether this first condition or second condition. Now I draw the second condition, Vs minus V out. It will be a negative value. I will draw at the negative point, Vs minus V out. The main reason is I'm measuring the voltage between these 2 points A and B. Now you can see we are getting negative voltage between A and B. Here the polarity at point A is minus and polarity at point B is positive. Then I am getting a negative voltage. Then I use this second equation. It is a negative value. VL is equal to Vs minus V out. Then I draw the negative voltage here. Now we have to derive the output voltage equation. From the duty cycle value of D and input voltage Vs. For that one, we can use the current balance equation, delta IL on plus delta IL off is equal to 0 at continuous conduction mode. And for the delta IL, we can write VL times delta T over L. I derived that equation in the previous buck converter video. Then we can apply this equation for turn on time and turn off time. For the Q is on, we can write delta IL on is equal to VL, the inductor voltage. From this graph, we can get Vs minus Vs. And delta T, it is dTs over inductor value L. And Q is off, we can write delta IL off is equal to the inductor voltage. From this one we can get Vs minus Vout, Vs minus Vout into this time duration is dTs minus Ts, Ts minus dTs, Ts minus dTs. This time is Ts and this time is dTs. Then this delta T is Ts minus dTs over inductor value is L. We can write again Vs minus Vout. We can get Ts out 1 minus d Ts over L. Then we can assign these two values to this equation. Delta IL on plus delta IL off is equal to 0. Delta IL on is Vs dTs over L plus for the delta IL of Vs minus Vout one minus d Ts over L is equal to 0. From this equation, we can cancel this L and Ts common for both the parts. And then we can write d times Vs plus Vs into 1 minus d into Vs, Vs into minus d minus Vout into 1 minus Vout into minus d minus into minus is plus Vout d is equal to 0. From this equation, there is a plus dVs and minus dVs. Then these two will cancel. And then Vs minus Vout plus Vout into d is equal to 0. From these two, we can get Vs minus 1 minus d into Vout is equal to 0. And Vs is equal to 1 minus d into Vout. And from this, we can get Vout is equal to 1 over 1 minus d into Vs. This is the equation for output voltage of boost converter. According to this equation, you can see if the d value is 0.5, assume my d value is 0.5, duty cycle is 0.5. That means this is Ts over 2. These two times are equal. If d is equal to 0.5, 1 over 1 minus 0.5, that means 1 over 0.5. This part is greater than 1, then I can obtain Vout is always greater than Vs. For any d value, you can obtain a output voltage that is greater than the input voltage Vs. 1 over 1 minus d, it is giving always greater than 1 value. D is always less than 1. As I explained in the previous video also, D is always less than 1. Then for the 1 over 1 minus D, we can obtain always greater than 1 value. Then the output voltage is always greater than the input voltage. And that is the operation of boost converter and how we are going to obtain the output voltage equation from the input voltage and the duty cycle of the switch. I hope you all understood the operation of boost converter and how the output equation is defined. Thank you.